Hi everyone, I am Dr. Peiris. Welcome to the classroom. So today we are going to talk about quadratic functions and what is the general form of the quadratic function. So let's see what is the general form of a quadratic function first, and then I'll explain you the characteristics of parabolas like intercepts, vertex and axis of symmetry. Then we'll see how to graph the parabolas. The general form of a quadratic function is given by this equation: f of x equals ax squared plus bx plus c. A, b, c are real numbers and a cannot be equal to 0 because we need the quadratic term ax squared. So this term must be there to have a quadratic function. So the coefficient a cannot be equal to 0. For example, this 2x squared minus 3x plus 8 represent a quadratic function. The value of the a is equal to 2, that is the first coefficient. Value of the b is negative 3. Value of the c is equal to 8. So what are the characteristics of parabolas? The graph of a quadratic function is a parabola. So if we graph a function in this form, in the quadratic form, ax squared plus bx plus c, we will get a parabola like this. And these parabolas have different characteristics. The first thing is the parabola is a symmetric function. So it is going to be symmetric around this axis of symmetry. As well as sometimes the parabolas can intercept the x-axis. So we will have the x-intercepts like shown in here. As well as there could be a y-intercept. And this bottom point called the vertex. It depends on if the parabola is open upward or downward. So you can have a parabola going like this way. This is a parabola too. This is a parabola open downward. So in that case, the vertex will be on the top. We will discuss that when we do the examples. So depending on the values of the a, b and c, we can find these axis of symmetry, vertex, x and y intercepts. So based on the values a, b and c, if the a is greater than 0, the parabola opens upward. If the a less than 0, the parabola opens downward. And the axis of symmetry can be found using this relationship. So the axis of symmetry, this is a vertical line which crosses the x-axis, which means this is a line of x equals a number. So that number can be found using minus b over 2a. The axis of symmetry is given as x equals minus b over 2a. So if it is the axis of symmetry, the vertex need to have the same x coordinate as the axis of symmetry, because the vertex all the time lie on the axis of symmetry. The x coordinate of the vertex is same as the axis of symmetry. The x coordinate of the vertex is minus b over 2a. Now how do we find the y coordinate of the vertex? If we know the x, we can substitute that x in the given function to find the y coordinate of the vertex. And to find the x-intercepts, we know that we need to make the y equal 0, because at the x-intercepts at this point and at this x-intercept, the y value is 0. So by making the y value equal to 0, we can find the x-intercept. Similarly, to find the y-intercept, we need to make x equal 0. So here is the y-intercept. So at this point, the value of the x is 0. So by substituting x equals 0, we can find the y-intercept. Now let's see a few examples, and let's see how do we find these characteristics of parabolas and then how to graph them. So first we need to graph this quadratic function f of x equals x squared plus 2x minus 1. The first thing is to identify what is a, b and c. The a is equal to the coefficient of the x squared term. So in this case, the coefficient is 1, a is 1, b is 2, c is negative 1. So that is the first thing that we can do, write them down to make it simple. A equals 1, b equals 2, c equals negative 1. Then we can find the axis of symmetry using the relationship x equals minus b over 2a. So let's find it. Minus b is 2, 2 times a is 1. So which means negative 2 over 2 is negative 1. The axis of symmetry is x equals negative 1. So which means it must be the same for the x coordinate of the vertex. The x coordinate of the vertex is negative 1. To find the y coordinate, we substitute the x coordinate of the vertex into the given equation. So basically we find f of negative 1, substitute negative 1 in the given equation. The x value is equal to negative 1. So f of negative 1 is negative 1 squared plus 2 times negative 1 minus 1. So what I did was I found the x coordinate of the vertex as negative 1. Then I need to substitute that in the given equation to find the corresponding y value. So x is equal to negative 1. This is negative 1 squared plus 2 times negative 1 minus 1. Then you can simply simplify it. Negative 1 squared is 1 plus 2 times negative 1 is minus 2 minus 1. This equals to negative 2. So which means we found the vertex as negative 1 comma negative 2. That is the vertex. So we found the axis of symmetry and the vertex here. Now let's see how do we find the intercept. First thing I'm going to show you how to find the x-intercept. To find the x-intercept we need to make the y value equal to 0. So we substitute f of x equal to 0 in the given quadratic function. Then you need to solve this for x. So the first thing is to see if this can be factored. If not, we use the quadratic formula. So this one doesn't look like we can factor it out. So let's find the solution using the quadratic formula. So I hope everybody knows how to use the quadratic formula, but I'm just going to show you the formula. Minus b plus or minus b squared minus 4ac over 2a. So that's the quadratic formula to find the x. So if we apply that, here our b is 2 minus b plus or minus, so the b squared is 2 squared, which is 4, minus 4, a is 1, c is negative 1, divided by 2 times a is equal to 1. So if we simplify this, minus 2 plus or minus negative 4 times negative 1 becomes positive 4, divided by 2, negative 2 plus or minus square root of 8 over 2. This is the x. Now we need to simplify the square root of 2. The square root of 8 is 4 times 2, which means radical 4 times radical 2, and radical 4 is 2. So this can be written as 2 radical 2 over 2. Now the 2 is common for each and every term, so we can cancel out the 2 from each. It must be there in each and every term to cancel out. So which means this becomes negative 1 plus or minus radical 2. So these are the x-intercepts. Negative 1 plus or minus radical 2. That's the x-intercept. To find y-intercepts, we substitute x equals 0 in the given quadratic function. Then we can find the corresponding y value. So if we do that, f of x equals, x is 0, so 0 squared plus 2 times 0 minus 1. So which means this becomes f of 0 is equal to negative 1. So the y-intercept is 0 comma negative 1. That's the y-intercept. Now we have everything that we need to make the graph of the parabola. So the first thing is to define is the parabola going to open up or down. So we need to look at the value of the a is equal to 1, which is greater than 0, which means the parabola opens upward. Now everything else we found. Now you can basically mark these points and the axis of symmetry on the parabola. Then we can draw the parabola. The axis of symmetry is x equals negative 1. So that is the first thing we're going to mark, x equals negative 1. So here is the axis of symmetry. And then the vertex is negative 1 minus 2. So here is the vertex, negative 1 minus 2. The y-intercept is 0 comma negative 1. That's right here. And then the x-intercepts. So negative 1 plus radical 2. The radical 2 is equal to 1.414 something. So the negative 1 plus radical 2 is equal to negative 1 plus 1.414, which is basically 0.414. And the negative 1 minus 2, this is the second x-intercept. Negative 1 minus radical 2 is 1.414. This equals to minus 2.414. So these are the rough approximations for these two x-intercepts. So the first one is 0.414, which is less than 1. So you can just mark it in between 0 and 1. The next one is negative 2.414, in between negative 2 and negative 3. So once we mark the x-intercepts and once we draw the parabola, we must see it must be symmetric around the axis of symmetry. So just connect the dots, make sure that we draw this as a parabola. This is a curve, not a straight line. So this continues. So these are the only special points that we need to mark when we draw the parabolas. So this is the first example. Now let's see another example. So this one is 2x squared minus 4x plus 5. So what is the value of the a? Is 2, b is negative 4, c is 5. The axis of symmetry is x equals minus b over 2a, minus the b is minus 4, 2 times a is 2. So minus times negative 4 is positive 4 over 4 is 1. Similarly, the x-coordinate of vertex is 1. Now to find the y-coordinate of the vertex, we substitute 1 in the given equation. 2 times 1 squared minus 4 1 plus 5. So basically I found the x-coordinate of the vertex is equal to 1. To find the y-coordinate, this value must be substituted in this given quadratic function. So 2 times 1 square minus 4 times 1 plus 5. Then we simplify it. This 2 minus 4 plus 5 is going to be 3. So the vertex is 1 comma 3. We found the vertex. Now let's find the x-intercepts. So to find the x-intercept, we make f of x equal to 0. So the left hand side becomes 0. Now we need to solve this for the x. So again you can see if it is factorable. If not, we must use the quadratic function to find the factors. So this doesn't seem to be having factors, so let's use the quadratic function. X equals minus b plus or minus b squared minus 4ac divided by 2a. So the first one minus 4 is positive 4. Then negative 4 squared is 16. Negative 4 times 2 times 5. Negative 40 divided by 4. Now what we see in this case, this is a special case. So inside the square root is a negative number. 16 minus 40, which is minus 24 divided by 4. So it's going to be an imaginary number. This is square root of negative 24, which means there are no x-intercepts because this is not real. Which means in this case no x-intercept because we are finding a negative 24. This is imaginary. This is going to be imaginary because this is negative. So this means in this particular case there is no x-intercept. No x-intercepts. So that is something special to remember. If there is x-intercept or not, you can basically see if the solution for the x becomes real or imaginary. Let's see how to find the y-intercept. So again we substitute x equals 0 to find the y-intercept. 2 times 0 squared minus 4 times 0 plus 5. So this is equal to 5. The y-intercept is 0, 5. We found everything, then we can simply graph it. So again in this case a is equal to 2, which means parabola opens upward because a greater than 0. We found the axis of symmetry 1, vertex is 1, 3, and no x-intercept, y-intercept is at 0, 5. Now let's mark the axis of symmetry first. X equals 1. So here is x equals 1. Then we mark the vertex 1, 3. So you see that vertex is right over here. That is why there is no x-intercepts. And the y-intercept is 0, 5. Y-intercept is 0, 5. So we have 2 points. So we need at least one more point on the right hand side to make the graph properly. So you see on the left hand side, see at 0 it is 5, and the axis of symmetry is at x equals 1, which means if within 1 unit, if the value becomes 5, so on the right hand side also within 1 unit the y value need to become 5. So if you want, you can substitute another value and see if you get the 5 when x equals 2. Then we can simply connect the dots. This is the parabola. So this third point, if you want to find that using the substitution method, what you can do, you can pick a point on this side on the x-axis and then substitute here to find the third point. But simply since this parabola is a symmetric curve, if you know the axis of symmetry, and if you know one point on the left hand side, it must be the same on the right hand side. But let me show you how do we get 5. I'm just going to substitute x equals 2 in the given equation, and then let's see if we are getting y equals 5. So we're going to substitute x equals 2 times 2 squared minus 4 times 2 plus 5. The first one is 2 squared is 4 times 2, 8 minus 8 plus 5. So f of 2 equals 5. So we are right. It must be correct. Where at x equals 2, the y value is 5. So in this case, if you look at the parabola, we see that there are no x-intercepts. So our calculations are correct. So there could be some cases that the parabola do not intersect the x-axis. Another example. So let's see this example. So in this case, negative x squared plus 4x minus 3. So the a equal to negative 1, b equals 4, c equals negative 3. The axis of symmetry minus b over 2a is negative 1. So negative 4 over negative 2, which is positive 2. The x coordinate of the vertex is also 2. Now to find the y coordinate of the vertex, we substitute x equals 2 in the given equation. So we are finding f of 2, negative 2 squared plus 4 times 2 minus 3. So this one has to be minus 4. We have to be very careful. There is no parenthesis in here. It is first 2 squared and then multiply by negative sign. 2 squared is 4 times the negative sign is negative 4. 4 times 2 is 8 minus 3. So this gives us 1. So the vertex is 2, 1. Vertex is 2, 1. Similarly, we find the x-intercept by substituting f of x equals 0 minus 3. So whenever you have a negative sign with the square term, the best thing is to get rid of the negative sign, which means you must switch the sign of each and every term. So we make this positive, the positive becomes negative, and the negatives become positive. Then we can see if we can factor this out. So this one is easily factorable. The factors are x minus 3, x minus 1. Negative 3 times negative 1 is positive 3. Minus 3 minus 1 is minus 4. Which means x equals 3 and x equals 1. So the x-intercepts are 3, 0 and 1, 0. So this one was easy because there were factors. If there are factors, it is very easy to find the x-intercepts. To find the y-intercept, we substitute x equals 0. So 0 plus 0 minus 3. So which means the y-intercept is 0, negative 3. Now we found everything. Now let's look at the value of the a, which is negative 1. If it is negative 1 less than 0, that means the parabola opens downward. And we found everything else. So let's draw the axis of symmetry. X equals 2. X equals 2 right here. And the vertex is 2, 1. Right here. X-intercept is 3, 0. And then 1, 0. The y-intercept is 0, negative 3 right here. So you see how the points look like. So that definitely tells us the parabola opens downward. Now we connect the dots. Now this is our graph. This is the parabola. So this is the same method that we follow in each and every question. The only difference actually comes in when you find the x-intercept. Sometimes it is easy that you can find the factors very easily. Sometimes you might have to use the quadratic equation to find the factors or the solutions for the x-intercept. So if the solution of the x-intercept becomes imaginary, which means there are no x-intercepts. So that's all for today, everyone. So please subscribe to my YouTube channel, Dr. Peiris Classroom, as well as visit my website drpeirisclassroom.com for more videos of other classes also. Thanks for watching, everyone. I'll meet you again with another video. Bye.